Welcome everyone. My name is Andrea Aime. I work for GeoSolutions, an international company with offices in Italy and the United States. We offer services around a number of open source projects, of which we are typically core developers. And as a company, we believe in open source, open standards, and well, that's why we have this big presence at a conference like FOSS4G. Today, we are going to talk about Earth observation, so how to collect, search, display, and download Earth observation data using GeoServer. First step, search. The first thing that we need to know is how to find the raster data that we want. The primary search engine at this point is the STAC API community module. STAC API is an OpenAPI-based OpenAPI features compatible implementation that allows to search for raster data. The idea is that you have collections, which are uniform sets of products which are retrieved from satellites. The single product is typically a scene, but it could be something else. It could be a composite. And the product then links to assets. The assets are the single files that compose the product. It could be the raster bands of a Sentinel-2, 13 different files at different resolutions, but then also the metadata and any other information attached to the product. And the idea is that this API allows you to locate all the images which are relevant to your use case and then fetch directly the files that you need out of them. This is a screenshot of the landing page of a STAC API. As an OGC API, it has, of course, a landing page, which is your entry point. As you can see, you can get the list of collection, the cross-collection search endpoint, which allows to perform queries across different satellites if you need, and a list of queryable that allows to build complex filters like give me everything in this area within this time range with cloud cover less than 30%, with, I don't know, snow cover less than 10%, and so on and so on. This is a customized version of the collections page. All of these HTML representation of the resources are customizable through templates, and this is what DLR came up with. DLR is the German space agency. This is the page for a single collection with all the details. These are items out of a collection. Items are the products, the single scenes, let's say, with, again, all the properties displayed. And this is an example of a single product page with all the links to the assets on the right, little viewer which allows to see where the asset is located, the preview with the thumbnail, and so on, and the ability to download the data in a variety of protocols. In addition to that, on top of the same database, we also offer OpenSearch for EO, which is a previous attempt by OGC to allow searching for satellite imagery in general. It was based on the OpenSearch specification, which was, a specification to do an open source, an open protocol search engine. So it was sort of Google for everyone. And on top of that, OGC created the OpenSearch Geo and Time specification, which allowed to search on space and time as well. And on top of that, OGC OpenSearch for EO was created. This is back in 2017. This is an example search that I'm doing. So give me everything on Sentinel-2 that has from 0 to 30 cloud cover. The output is typically RSS, so a little bit outdated, but since 2021 in GeoServer you can also get GeoJSON as an output. What I think is interesting when it comes to the OpenSearch for EO is its attention to linking to other OGC services like WMS, WMTS, WFS, WCS. So if you think about the STAC API, it's gearing towards letting you download the assets, the files directly, raw data, all of it. Even if you maybe don't need all of the data in a particular scene. And instead, OpenSearch for EO was more geared towards giving you services to consume directly the imagery and eventually to decide what to download later. This doesn't mean that you cannot do it with STAC. As a OGC API, you can add whatever link you want to the output. So you could be linking to the capabilities documents of OGC services and other OGC APIs to consume the data. But the focus is a little bit different. In both cases, there is a REST API to manage the search index, which is an administrative API, so we don't expose it to the end users, and it allows to create new collections, new layers out of collections, upload and destroy products and assets, and so on. Okay, let's say that we found the data that we want. How do we access the raster data? So as I said, STAC has the assets. OpenSearch can point to the raw package. Where can they be located? Well, a few options. With STAC, what goes as the most common scenario is to point to Cloud Optimized GeoTIFFs stored in blob stores like AWS S3, Google Storage, Azure Storage, and so on. But you could point to any random HTTP server as long as it supports range requests, or it could be the classic and tried and true file system. Already talked about COGs. They are, as I said, Cloud Optimized GeoTIFFs. We have two options in GeoServer: the COG plugin, which needs a COG structures and makes the best usage of its internals. But we also have an older S3 GeoTIFFs that can read from S3 any GeoTIFF, not just COG. Of course, it has a less performant approach, but it's interesting because it can read just any TIFF. So if you have a storage, or a larger storage of TIFFs already in S3, you don't have to reprocess them to make them COGs. The COG plugin instead, as I said, leverages the structure of the COG to make efficient requests and just grab the part that are needed. Now, let's say that I also located the rasters that I want to make a map. In GeoServer, we have this plugin called Image Mosaic that can take several images located in space and time and prepare a mosaic out of them. The simplest approach to locate them is to have, a mosaic index, which in its simplest incarnation is a table that contains a location of the files, the footprint, and eventually time, elevation, and whatever other attribute you would like to use to do filtering. So it could contain cloud cover, snow cover, whatever. But in addition to that, we can have a call to a remote STAC API to be used as an index, and we allow to plug in whatever other index you might already have in-house. Some companies already have their own internal catalog. They want to use it directly, and it's possible. In terms of mosaicing, there's complete freedom. You can have images in the mosaic with different coordinate reference system, different resolution, different color model within reason. We can mix RGB and gray and having alpha or not having alpha. And so, yeah, you can put together a variety of things. In terms of dimensions, as I said, they are typically attributes in the index table that can then be exposed through WMST. So the capabilities document will contain the list of available times. If you have a very large catalog, that becomes a little bit problematic because the capabilities document will become too big. In that case, we have a second protocol that allows to discover what times are available for a given location in space, or what run times are available for a given predicted time if you're doing weather forecasts and stuff like that. It's not an OGC API. It's one thing that we grew during a testbed with OGC, but it didn't become a standard. So, in terms of indexing, as I said, relational database, but you can use the internal STAC server as an index for the image mosaic. So through that administrative REST API, I can tell GeoServer, okay, could you please create for me an image mosaic out of that collection, taking these 3 bands and make a false color image? Boom, it's done. You can create that virtual layer on the fly. You can use an external STAC API as an index. So I go to one of these, I don't know, Sentinel 2, Landsat 8 STAC API, and I underline API, not catalog, I need something which is dynamic that allows me to do queries. And I can use that as my index for the image mosaic, doing all the filtering that I want to do using the search endpoint. So again, filter by any attribute attached to the products. If you want to download the presentation later, I got a bunch of documentation links from the reference documentation and the trainings. We will have them also later for the other sections. Okay, image mosaic, the fun stuff. Well, as I said, we can do filtering and sorting. This is pretty important when doing a display of multiple images, because maybe you wanted to put on top the less cloudy images when you are displaying a range of images, or maybe the most recent images instead. And of course, you can do filtering on the fly, as I mentioned already multiple times, grabbing a certain range of time, ensuring that you are getting a particular satellite, a particular cloud coverage, and so on. You can do coverage views. Coverage views are this interesting idea that I can take eventually multiple files that I have on disk, which are separate rasters, and bring them together to form a virtual raster, a virtual multi-band raster. So we do it all the time with Sentinel-2 because there are 13 files at different resolution, 10, 20, and 60 meters, and we put them back together into a virtual 10 meters raster, which is resampled on the fly as needed. And we do it also, for example, when you have wind maps. You maybe have a netCDF with two variables, which are the projection of the vector of the wind on the two axes. We put them back together from the two variables into one, and then with those two values, we can do wind maps. I just mentioned native multi-coverage support. This is exactly the Sentinel-2 case where I have all the files and I'm bringing them together into a virtual raster. In GeoServer, we recently developed better support for hyperspectral imagery. So, what's hyperspectral? Well, once upon a time we had images which were so well behaved. 1 band, 3 bands, 4 bands, all the same resolution, and so on. Then we started having this sensor that could do multiple resolution, multiple wavelengths, and we went multispectral. 10 bands, 20 bands pushing it. And now we have these sensors that can do 200 bands, 1,000 bands. And these are called hyperspectral. Of course, having to deal with this many bands creates a problem of its own. Size, when it comes big, it's always a problem of its own. And so we had to improve the GeoServer ability to handle files with 200 bands or more. Documentation links for you later. How do we visualize? Well, WMS, of course, eventually with time support to know which times are available. Then, once we have time, we can do filtering. And this is nice because it's part of the standards. So a standard client can do filtering on the fly without using any GeoServer-specific extension. But if you need to, you can do SQL filter, which is a vendor parameter for GeoServer, which allows you to do on the rasters whatever kind of filtering you want. So you kind of continue from the search on OpenSearch or STAC to the visualization following the same filtering pattern. And you can also sort by cloud cover or time if you want. You can do rendering transformation on the fly, which is this idea that we can take WMS and WPS and put them together and transform data on the fly before rendering it. This is a use case where we are extracting ISO lines on the fly with the special optimization to make sure that the extraction is quick. This is one example. Here we have a few others: wind barbs, current arrows, raster algebra, in this case with GIFL. I take my Sentinel-2, take band 4 and 8. These indexes are zero-based, and compute NVI and display it on the fly. Compute whatever index you want once you have the 13 bands, and just stick it in the style. You don't have to pre-compute anything. Another set of links for you. Okay, let's say that you searched, you found, you displayed, you're happy. Now you want to grab the results. Download. First option, via WCS. This is the kind of the OGC classic way to do downloads. In GeoServer, we have an implementation of WCS 2.0. We also have 1.1 and 1.0, but do yourself a favor. Use 2.0. It's so much easier to use. Or you can try to experiment with OGC API coverages, which is a community module. And the implementation of WCS 2.0 is rather complete. We offer a variety of extensions like reprojection, scaling, interpolation, various output formats, and whatnot. WCS 2.0 can describe the rasters in, well, 4D, space, time, eventual elevation if you have it, custom dimensions, so go beyond the 4 dimensions if you need to. And then again, you can apply the exact same vendor parameters that you had in WMS to perform a download which is specific to your use case. So again, you can control the stacking of the mosaic, you can control the contents of the mosaic, and get as raw data exactly the same data that was used to make the pretty map that you liked so much before. But there's a catch. WCS as a protocol is a synchronous protocol. You make an HTTP request with all the parameters, and then you sit and wait for the raster to come back. It works great for small extractions, let's say less than a minute of computation to generate the output TIFF or the output netCDF. Pushing it maybe 5 minutes, but then something, the browser, a router, a proxy, something in between will say, HTTP timeout, I'm sorry. And you don't get your download anymore. So you need something that can do asynchronous request and maybe do that massive extraction that might take 20 minutes or 2 days, I don't know. So in this case, we need asynchronous, and the only protocol right now in classical GC services that can do asynchronous is web processing service. Web processing service is for spatial analysis, but really can do anything. If they invented WPS as the first protocol, they wouldn't have had to invent any other protocol because it can do literally anything. You can make a WPS process that makes you a coffee or order a pizza. It's literally just a remote procedure call. What it adds on top, which is interesting, is this idea that you can make asynchronous requests. So I submit my job, get back a link to check whether it's finished or not, check it periodically, polling, and then get the result when it's done. And with this, we have a dedicated process called WPS download, guess what? That can do large vector and large raster extractions. So you can submit your, give me all the images in that part of the United States at native resolution, and maybe you get a 25 gigabytes GeoTIFF compressed raster sometime later. Definitely not a minute later. But you can also do large render maps. So maybe you had that very nice and useful NDVI map that you wanted to download at full scale. 10 gigabytes NDVI at 2 meters resolution. Sure, there is another dedicated process which is called download map, which allows you to download the map that you are seeing in the browser at full scale. If you are not happy, well, you know, with Earth observation, you always have a time dimension. All the satellite images have a time attached, so it's kind of natural to do time travel using the user interface, but also time animation. So give me this time range, animate all the images that you have over time. And what you can do with the download animation process is to create a movie of the data, which again can take quite a bit of time to generate, but then you can download it at ease when it's done. And this is the end.